A party of 12 people is going to Universal Studios in 3 different cars, with 4 people in each car. Each car is driven by its owner. Find the number of ways in which the remaining 9 people may be allocated to the cars. The arrangement of people within a particular car is not relevant. This last part here just says we don't need to care about who's in the front seat and who's in the back seat. So if you imagine this, we've got our 3 cars, and please don't mind my artwork, I'm not very good at drawing cars. And we've got our driver fixed in the front. So he or she can't be moved, right? That means that I've got 9 people remaining out of the 12. So what's the first thing I have to do? Well, I've got 9 people. I'm going to choose 3 of them to go into this car, right? That leaves me with 6 people remaining. I'm going to choose 3 of them to go into this car. That leaves me with 3 people remaining. I'm going to choose 3 of them to go into this car. Multiplying these combinatorials together, I get 1,680 ways. So let's take a look at part B. At Universal Studios, they decide to split up into groups of 3, presumably the same 12, so 4 groups of 3. How many ways can they do this? Well, firstly, imagine just arranging the 12 people, 6, 7, 8, 9, 10, 11, 12, and then what am I going to do? I'm just going to break them up into groups of 3, right? And then within these 3, it's all going to be indistinguishable. So that means that I've got 12 factorial ways of arranging them in the first place, and then I need to divide through by the number of ways of arranging them in the group. Like there's no first person in the group, second person in the group, third person in the group. You're just in the group. You don't have an order, right? So we divide through by the number of ways of arranging them in the groups. So 3 factorial to get rid of the arrangement of the first group, 3 factorial to get rid of the arrangement in the second group, 3 factorial to get rid of the arrangement in the third group, 3 factorial to get rid of the arrangement in the fourth group. But the groups themselves also doesn't matter, right? So like if this was person A, B, C, and then D, E, F was here, if we had like D, E, F, A, B, C, that's exactly the same. Like there's no group 1, group 2, group 3, there's just groups. So we also need to divide through by 4 factorial to get rid of the arrangement of the groups themselves. So performing this calculation, you find that your final answer is 15,400. Please note that this is different to the answer provided in the answers at the back of your tutorial. So this is the correct answer. You need to divide through by 4 factorial, not divide through by 4. Your final answer should be 15,400.